Okay, good. Okay. Um, we just want to be sure that more and more people can, watch the event tonight. For those that couldn't make it, we've had some people call in the office and say that they couldn't be here tonight, but they really wanted to get the information that comes from this program. So anyway, hi, I'm Sandy Galiff, New York State Assemblywoman, and I want to thank all of you for joining us this evening. We're very excited to have you all here for a program that we think will be very, very informational and very topical. And our virtual town hall is about the New York energy grid transition and heat pumps 101. And the reason the heat pumps 101 was I had actually gone to a demonstration in Osnane at one of the town parks where they had
come up with a blinking blue in order to pair,
which they had just put a heat pump in. Yeah. And I really got very excited about it, wanted to learn more about it. So you're all a part of me learning more about it, and hopefully you will do the same. New York is certainly one of the states that is leading in the nation when it comes to addressing climate change, and a major piece of our puzzle is the energy grid, going toward renewable sources and also ensuring that our grid is reliable in the face of increasing severe weather events. And we've just been through a summer of very hot weather. And Bruce Shriver, can you just put yourself on
over there,
mute?
that Hindi speaker.
If you could put
your how I could connect to that in a different computer.
If everybody could just put themselves on mute, that would be helpful. That'd be great. Okay. And tonight we're going to hear an update from Kevin Lenahan of the New York Independent System Operators on the state of the grid and the impact of electrification. And
just move it.
Bruce Shriver.
Nothing, I wouldn't think so.
Can you just
oh,
Claire, if you make me a co-host, I'll help you mute.
Why aren't we connecting?
Okay, he's having trouble. We all go through this. We do this at times. So we are going to have Kevin talk a little bit about what's happening in our whole system in New York State. But another piece of what we're going to be speaking about today is obviously the alternative heating and cooling in our homes, and that's through heat pumps. And
quick.
We'll hear from Lauren Royce of Sustainable Westchester and Joe Monturo of Sustainable Putnam, who will break down the heat pump technology and how it works and explain the process and opportunities for switching to a heat pump for home energy, heating and cooling needs. And finally, we're going to have some local contractors on that can give us an explanation of the installment.
Okay, wait, Sandy, you got to unmute yourself. Sorry, Claire muted everybody.
Okay,
just helpful.
Okay, that helps. Okay, thanks. So we're going to start with Kevin Lenahan, and we're going to try to keep questions. If we might have a few questions for him, but we may keep the questions to the end of all the presentations. But we'll see how it goes time-wise. Kevin Lenahan is Vice President of External Affairs with New York Independent System Operator. He is an experienced energy professional with 25 years of industry experience with both Con Ed and National Grid. And he served as acting executive director of the New York State Energy Association and as a board member for the Center for Economic Growth. I've been to the facility with the New York State independent operators, and it's just amazing what they do. And I think it's important for us to have an idea of where we're going in New York State, what our needs are, and what we need to do about that in the future. So, Kevin, your time.
Well, thank you, Sandy. It's a pleasure to be with you again. I really enjoy these forums and interacting with the constituents, and these are really interesting times for the energy industry, and happy to talk about what's happening with the system and the grid, what we need to do in order to meet the goals, the ambitious goals that New York State has with the Climate Leadership and Community Protection Act. So that's what I hope to do today, is give folks an idea of the state of the grid as we have it now, and then what's going to be required of us to get to those ambitious 2030, 2040 goals, decarbonize the electric system, connect more renewables, and what's happening. You know, what are some of the things that we're seeing as we advance this work? So we'll run through some slides that might look a little complex, but I hope to distill it down for folks. Like Sandy said, we'll get to some questions. And just happy to be with you folks today to talk about these things. So Claire, whenever you're ready to put the slide deck up, I'm ready to get going. All right, and the slide number 2 there will show what Assemblywoman Gale was talking about. That picture on the right there is our control room. So we are based in upstate New York, across from the Capitol in Rensselaer County. Not everybody knows that we're there. Not everybody knows exactly what we do. You're familiar with your utility company, National Grid, Con Edison. We kind of operate at the wholesale level with dispatching the electrons from the generators onto the big transmission lines, making sure that happens reliably and safely, and delivering those electrons down to the utilities, kind of handing off the energy to the distribution system and letting them work with their system to provide the energy necessary to serve the consumer. We're behind that, operating those big transmission lines and working directly with the generators across the state. We'll get to what those generators look like and the changes that we're seeing with those assets. But our mission, we were set up in 1998. Our mission is to keep the system reliable and oversee and run the competitive wholesale electric markets, make sure that happens transparently, make sure that happens fairly at the lowest cost possible. And this is new for us as part of the mission, but our mission is also to help deliver and develop the cleanest electric system in the nation, pursuant to those state goals that we mentioned before. So we can move to the next slide, Claire. And I just want to run through some specific responsibilities we have. I mentioned that reliability aspect. That has always been part of our charge, always part of our mission. It is the responsibility that we have that was given to us by the Federal Energy Regulatory Commission when we were set up, and the state of New York. We are not a state entity. We are not a state agency. We are independent, nonpartisan, and our budgets are completely transparent. Heavily regulated by the Public Service Commission, Federal Energy Regulatory Commission, as I mentioned. All the rules under which we operate the system and make sure we do so reliably. Those rules are developed by stakeholders, including the state of New York, consumer groups and advocates, environmental advocates, and industry professionals. It's done so through a transparent procedure and overseen, as I mentioned, by those regulatory agencies. The same goes for operating the wholesale electric markets. We do so according to federal tariff, a lot of complex rules, very strict reliability rules, very strict rules for the fairness of the markets. And the other responsibility we have is to look into the future, roughly on a 10-year time frame, although we're looking farther into the future now because all of our goals are up to 2040 on a 20-year time frame. what are the changes we're seeing on the electric system? And there's so many today. There's so many that are so many changes that are happening because of the policies, so many changes that are happening because of the advance of technologies, and that's part of what we're going to talk about today. So we have to look at those changes, forecast what the impacts can be to reliability, to competition, to the way that consumers want to get their electricity, and we have to get the system ready long before those changes happen. And that's also part of what we're going to talk about today. And then our last charge is what we're doing here today is taking all the information that our very smart engineers, economists, and scientists are seeing and putting in reports and making sure it gets to you folks today. Next slide, Claire. So very quickly, I just want to run through some of the themes of what those changes are that we're seeing. Our system is becoming increasingly dynamic and decentralized, meaning those big central station power plants are delivering less of the electricity that we need. We're seeing a lot of rooftop solar. We're seeing storage come onto the system. We're seeing a lot of wind and a lot of solar. And the wind is becoming different too. It used to be just land-based wind. We're seeing the development of offshore wind. It's taking some time, but we're seeing progress there. That means that our system is becoming more weather dependent, and that has certain attributes that we need to deal with. We also are needing to construct more transmission to deliver all of those green electrons, the renewable energy across the state. The biggest load centers, the biggest demand is in Westchester County, Long Island, New York City, the 5 boroughs. We need to get all of those clean electrons and all of that renewable generation that's mostly in upstate New York down to you folks. And we're going to have to invest in additional generation to achieve those goals of 2030 and 2040 for reliability purposes. Next slide, Claire. More themes. As we advance with the clean energy future, the grid and transition, more intermittent renewable generation like wind and solar, we are starting to see some of the reliability margins that we've so depended on for years begin to shrink. This was expected, but it's something that we need to adjust and plan for. And we're starting to see a lot more fossil fuels beginning to retire off the system. We expected that, but that means we need to build and connect to the system more big renewable assets. And we can't, as this second bullet says here, we've got to be careful that we do not have delays in the construction of that. We need to move those projects forward quickly so that we can meet the reliability rules that are in place. And moving forward, we're going to need new technologies that maybe we do not have yet today. Those technologies need to be emissions free, and they will help us with keeping the system reliable. So that's an interesting part of the technology equation going forward. Next slide, Claire. So now we'll just run through what does the system look like today and where are we going? Can move to the next slide. So we coined this phrase a few years ago at the New York ISO when we were starting to see some of these changes that are now upon us, that we really have two very different electric grids in the state. And if you look at the lighter gray shade, that is what we consider to be, in this case, upstate. And our upstate grid is, as you see to the left on that donut chart there, mostly emissions free right now. We have a lot of nuclear upstate New York. We have a ton of hydro assets upstate New York. We have more and more wind upstate New York. To the right of that is the darker gray shade. And that section of our state, and that second grid, as we call it, is predominantly fossil fuel based still, especially in Long Island, New York City. We have a lot of natural gas and oil, and some of those plants burn both. That is predominant. Those plants are predominantly located in the areas that you see to the right. And this it further highlights the amount of transmission development that we need to change that second grid with the darker shade to look more like the other. so that we can start to reduce the emissions profile, start to retire some of those fossil fuel assets, and build out more of the renewable generation across the state as we start to get closer to 2030. And by the way, I didn't mention, but for those that aren't familiar, the Climate Leadership Community Protection Act requires 70% renewables by 2030 and 100% emission-free electric grid by 2040. So those are the goals that we're working towards. Next slide, Claire. All right, so in consideration of some of the heat pump discussion later on, I just want to point out what we are starting to see as we work towards those 2040 goals. A reminder, the 2040 goal is a 100% emissions-free electric system. If you look at let's look at the winter lines, and the dark blue line at the bottom, that's how our winter load shape looks today. Roughly around 3 o'clock, we start to see a ramp up of the demand, and that continues till 6 o'clock. But we're counting on in the winter of roughly between 20 and 25,000 megawatts to serve that demand right now. That's currently. In the future, at 2040, you can see that the amount of generation that we're needing to serve the load and the demand roughly doubles. And we're looking at 40 to 45,000 megawatts to serve winter demand in 2040. That is because we are anticipating all those heat pumps being connected. We're anticipating electric vehicles. We're anticipating an electrification of appliances and our system to meet those 2040 goals. So that comes with significant challenges. We're going to talk a little bit later about what some of the impacts of electric vehicles might be. But this gives you an idea of how much change in the system we're anticipating. Right now, we are a summer peaking system. If you look at those green lines, we will become a winter peaking system, and that means changes for the system and how we run that system and the decisions that the operators in that picture of the control room will be making in the years to come. Next slide, Claire. Thanks. This just further illustrates the amount of generation that we need to develop to meet those demands. And as I mentioned, we are going to need a significant amount of new generation to meet the needs in the winter going forward. This summer, this articulates a little bit clearer the amount of generation needed to meet the winter or the summer peaks. And it's not as much, but we are going to need additional generation to meet this evolving summer peak. More and more of that is going to be intermittent. It's going to be wind, it's going to be solar, it will be storage. But that means that we have to be ready for when a sudden storm rolls in and then the solar is not available, or suddenly, as we did see this past summer, we had a wind lull of 4 or 5 days that was recorded even out in the New York Bight. So that poses an issue, especially in the summer when people are running their air conditioners. Next slide, Claire. I mentioned electric vehicles. So we're watching very closely what the state is doing on electric vehicle adoption and progress and policy. And Governor Hochul signed into law not long ago a requirement that after 2035, there shall be no more combustion engines sold in New York State. Well, we were anticipating, as I mentioned, that winter peak right about 2040. We're now expecting it to happen 2035, commensurate with the goals of the aggressive goals on EV adoption. So we have to be ready for that change, but we also have to be ready for changes in consumer behavior. If people are driving home from work at night around 5 o'clock, walking into their house at 5:30 or so, plugging in their electric vehicle overnight at that time, we're going to start to see that demand increase. Then they turn on their electric appliances and they turn up their heat pumps to heat their homes in winter. gives you a good illustration that not only do we have to be ready with the hardware and the machines and the equipment and the transmission infrastructure to serve all of that demand, but we also are going to have to start thinking about consumer behavior. And we are in discussions now with the Public Service Commission, the Edison Electric Institute, and others about how we can come up with ways to show consumers what the price is and what the demand is in real time, so that they can then start to change their behaviors. Maybe they can wait a few hours as they return home from work to plug in that electric vehicle. And it's these kinds of consumer behaviors that we're really going to have to pay close attention to as we work towards those 2030 and 2040 goals. Next slide, Claire. So storage will be a big component for meeting these goals, keeping the system reliable, helping us with those situations, as I mentioned before, where a pop-up storm happens and suddenly, solar generation is not available to serve needs. The issue with solar that we have to plan for, and this is the rate of adoption, the rate of development that we're anticipating over years. So it will be healthy, especially as the technology advances and becomes more efficient. But what we need to be careful with regard to storage is that the best kind of storage that we can anticipate is what we call hybrid, where it is co-located with solar or with wind, so that battery is charging with that renewable energy. Because if it's not co-located with storage, or we do not have enough renewable generation on the system to provide for the battery to charge up, then we're just drawing more from the traditional fossil fuel-based generation. And that's not what we need in order to develop this system, get it emissions-free, and make sure that storage provides the kind of profile that we need. Otherwise, storage just looks like additional electric load. It's drawing from those carbon electrons. That's not what we want. So we need to make sure that we, as I said earlier, we stay on pace with developing the renewable assets, getting them connected to the system, and where we can co-locate the storage, the battery storage with those renewable assets. Just another challenge. All right, we're going to go through these pretty quickly, and there's a lot of colors and numbers on these charts, but really what I want you to focus on for the next 2 or 3 slides here. This shows up this demonstrates what our lineup, if you will, looks like with regard to the generating assets that are on the system today. This is what's available to us. This is what the operators in the control room see up on the control room board. They know they have roughly almost 20,000 megawatts of what we call dual fuel capacity in the state to choose from if they need that. That number's been going down over the years because our wind and renewables is going up. But if you look at those numbers in the center of the donut chart, this is roughly what the number of megawatts on the system that they can choose from at any given point. But it also shows that we are still heavy on fossil fuels. And you see to the right in that big donut chart, the green, what the 2040 goal requires is that entire lineup is green. It is emissions free. So that's how far we have to go. We have roughly 25% emissions-free assets on the system currently to choose from. We have a long way to go. And if you look to the right, all you need to know is that the colors in the bottom, those are all mostly predominantly fossil fuel assets, and that's located in Westchester, New York City, 5 boroughs, and Long Island. That's the downstate system. The upstate system, again, we had that chart at the beginning of the presentation, more green. So that shows, again, the tale of 2 grids, but demonstrates how far we still have to go to decarbonize our system. The next slide, this is actually production. So the previous slide was, this is what's available to us. This is what we're producing on average for last year. So this is a bit of a better story it shows more green. So we're drawing and we're choosing from, because we have that availability to choose from, more emissions-free assets, a lot of hydro in upstate, a lot of nuclear, like I said. So this is a better story. This is actually what people are consuming. Generally a better story. But if you look again at that smaller donut chart to the bottom right, that's the downstate area. We still have a significant way to go in the downstate region. So that's what's being consumed in downstate. The next slide gives us a more specific idea of what 2040 will look like. The dark green is 33% is land-based wind. We are seeing a significant amount of development of that. The lighter shade green is the offshore wind that we're anticipating being built in the Long Island Bight. There is a lot of planning work and a lot of study work that is being done to site those assets. I want to draw your attention to the gray, because in our study work, we believe the New York ISO, like I mentioned, we have a lot of very smart planning engineers, economists, and they're looking at 2040 and saying the 2030 goal, and they're saying we have a lot of confidence if we stay on pace with the development that we need, that we can build and operate a system that is 70% renewables, wind, solar, and storage. With those assets, feel very confident we can get there. The question that's still unanswered is how to get from 2030 to 2040. And what we're concluding is that we're going to need some other technology that's more flexible than these than wind and solar and storage, that can ramp up really quickly when wind and storage or wind and solar isn't available, and that is also emissions free. Right now, that technology is not available commercially at scale. We're hopeful that it will be. There's a lot of good stuff in R&D, research and development, like blue and green hydrogen, maybe small scale nuclear. People don't like to talk about nuclear, so we don't really count on that. But we're going to have to develop some new technology to fill in that gray part to get to the 2040 goal and also keep the system reliable. Next slide, Claire. This is my final slide, and this shows what is in what we call our interconnection queue. So one of the responsibilities at the ISO is every time a major generating asset needs to connect to the system, they have to come to us, and we study that project for reliability purposes to make sure it's not going to have a negative impact on the greater electric grid. It's not going to cost consumers a significant amount of money nobody expected. We study each project individually, and then we're required to study them all the ones that want to connect to the system at the same time to see how they interact with one another for, again, reliability purposes. So this is what our planning engineers are studying right now. This is what is in our queue. So this is hopeful. We have almost 60,000 megawatts of wind in our queue right now. You see that storage number, pretty dramatic. And solar, pretty good. That doesn't mean that all of these projects will make it to the finish line. Oftentimes the developer will pull out of the process for various different reasons. One of the things that we do is we also, when we detect some investments that need to be made because this project is going to have an impact on the system, we tell them what the cost estimates are, and it's on them to pay that, not consumers. They have to make that investment. Sometimes they say we didn't count on it, so they pull themselves out of the project, and they wait and they use re-engineering. But this is still, I think, demonstrable of the impact and of the change of the CLCPA. It is a recognition that we are remaking grid. It will continue to accelerate. And again, I'm hopeful we can get to the 2030 goals. And I see some questions are popping up in the chat, and happy to answer those questions now or at the end. And pleased to be here.
Kevin, why don't you do them now? Miriam had a question about who pays for the services you provide with the independent system operator? Are you profit or not for profit? If you are profit, are you investor owned? Good question.
Very good questions. We are a 501(c) not-for-profit. And all of our budgets are completely transparent. And the way we put them together is pursuant to that, that governance process that I mentioned. So that means all the stakeholders, including the Public Service Commission, the Federal Energy Regulatory Commission, the consumer advocates, the environmental advocates, and several other utility entities are reviewing our budgets, commenting on them, telling us yes and no. As I mentioned, in the end, the PSC has to approve that budget. We have about a $250 million budget. It's not big considering what we do. The way that we operate the finances is that there is a very small, almost indetectable charge for every transaction that happens in the competitive marketplace. So a generator bids in, an entity buys the commodity from that generator. That transaction, there's a mill that's charged to the seller and the buyer in that case. That money comes to us, or it actually goes to the Public Service Commission, comes to us. That's how we operate our budgets.
Okay, and Bernie had a question about with the, I'm sorry, I just moved it. With electric vehicles, which you had a slide on, is that just cars or does it include trucks? What's the balance of need for trucks versus cars in the future for electric power?
Yeah, another good question. I don't know off the top of my head how to break down the percentage inside of the EV adoption, how much of it will be light duty trucks, passenger vehicles, and the big intermodal transport vehicles. I don't know that, but we are accounting for all of those categories.
Okay, I'm just going to take the next 3 questions and then we'll get on with the heat pumps and then we can come back to these. From Tom, the upstate grid is so much further along in green energy, which we saw. What has prevented the downstate grid from having moved more toward renewable fuel thus far? Is that because we say no to all projects? I'm just, it's an editorial comment.
It's a mix of things. And, you know, our system in New York is just so interesting. We have such diversity in terms of the kinds of power that we have to draw from. Significant amounts of hydro that has an impact on the profile for upstate. The nuclear plants were mostly sited historically in upstate New York because they wanted the tax base. They did not object. They also were easy to cite because the population centers in downstate drew concerns. Some say rightly so, and that's in large part why we no longer have Indian Point. So it was easier in many respects to build the central station fossil fuel, used to run predominantly on oil plants in the city. And as we know, this just brings up the EJ issues, and rightly so. And that's partly what we're trying to address with the CLCPA. But upstate is really a function of nuclear and hydro in terms of that disparity between green electrons and fossil fuel.
Okay, just following, Kyle had a discussion about, and it kind of follows up with this. It's upstate having much more open space for green energy development, and downstate having very expensive land prices. I guess that all factors
All
into
true.
it. Very little open space downstate.
All true. You know, where we're going to harvest the most wind is in upstate New York. That's why the Tug Hill Plateau, if anybody's driven through that part of upstate New York, you will be surprised at how many wind turbines are there. It's impressive. The other place to harvest the wind is in the Long Island Bight, and that's going to bring us at least 9,000 megawatts. It may, in the end, become more.
Okay, and just one more question, then we'll come back to them later. With, I think it's Terry. Sorry. how much of the natural ecosystem is going to be disrupted by these new technologies? I don't know that you get into that do you get into that as an issue or not?
No, we definitely watch the emissions rates, and we have watched the emissions rates before we ever began to talk about decarbonizing the system or the CLCPA or even some of the former programs that were run out of the Public Service Commission, because we knew that the competitive markets, when you pit generators against each other in the competitive markets, the most efficient one is likely the one that's going to get chosen more often. And so there was an incentive for the best technology at the lowest emissions to invest. But in terms of the impact that assets might have on the environment, those aren't studies that we do, and we try and remain resource neutral. Our main charge is reliability. And at those times, like we had some tight times over the summer. It was hot, and it was hot for long stretches of time. In those cases, our operators are in that room choosing some assets that are high emissions, because those are the ones that last resort that we need to meet that demand. Those are the times that we really need to plan for.
Right. And those were the times I think I was in my house with the air conditioning on.
Yeah, a lot of people were.
Oh, what a terrible summer. Anyway, well, thank you. Thank you so much, Kevin. And we'll come back later for some other questions. Now I'd like to ask Lauren Royce from Sustainable Westchester if she would come on. Lauren is the director of the Energy Smart Homes campaign with Sustainable Westchester. She's led the community adoption of solutions that help homeowners save energy. We can all use her expertise and money while making our homes more comfortable. She's involved with numerous sustainability initiatives across Westchester, including as a member of the Westchester County Climate Crisis Task Force. And with her is Joe Montori, Sustainable Putnam. We have a Sustainable Putnam, we have a Sustainable Westchester. I assume we have sustainable others around the state. No, we don't. Anyway, you'll tell us about that. Joe is the executive director of Sustainable Putnam, a local nonprofit that works to develop more sustainable and resilient communities in Putnam County. Prior to his time with Sustainable Putnam, Joe was a social studies teacher for 30 years, teaching courses including public policy and sustainability and society. And then following them will be two local contractors, which I'll introduce later on, or you both can introduce them. All right, Lauren, do you want to start?
Yes. Hi, everyone. You can hear me okay?
Yes.
Okay, good. Great. So as Assemblywoman Galiff was saying, I'm Lauren Bryce from Sustainable Westchester. I'm going to kick off our presentation about air source heat pumps, ground source heat pumps, and home energy efficiency, which is talking about insulation and air sealing. We want to let you know that no matter where you are in New York State, there are programs that exist for you. The utilities across the state are incentivizing people to move to heat pumps, and there are rebates and incentives from NYSERDA and from the utilities statewide. So we'll get into the specifics of all that, but I just want to differentiate. If you're in Westchester, if you're in Putnam, we have resources for you. So before I hand it off to Joe from Sustainable Putnam, just want to clarify that we are two different organizations. We both aim to serve the community with sustainability resources, but while we work together and are friends, we are two different organizations. So let's hear from Joe first about Sustainable Putnam.
Thanks, Lauren, and thanks to Sandy Galiff and to Claire for organizing tonight's presentations. So very quickly, Sustainable Putnam is a tax-exempt nonprofit. We're a 501c3. We are completely volunteer-based. There's no paid staff. I just get the fancy title, but no salary, which is fine. And our mission is, a large part of our mission is to help residents, businesses, and local governments, as well as other nonprofits, to reduce their carbon emissions, as well as to kind of develop better and increase our resilience as we face the challenges of climate change. And we aim to do that in a way that is going to be, financially responsible and obviously, ecologically sound and socially equitable. Next slide, please. And so, we have a number of programs, including community solar, which is actually, kind of contributing to more power, more clean power to the grid. We've got a program called 7 Steps to 100% Renewable Energy, which I'm going to talk a little bit more about on the next slide. And that is actually designed to help people to transition to clean renewable energy. And we've got a number of other, programs and partnerships that you can investigate on our website. Next slide. So this is a screenshot of one of our web pages. It's our 7 Steps toolkit, which helps people to transition. And if you go to that, navigate to that web page, you'll see a number of different things you can do. And if you go to the next slide, please. Here's the 7 steps. And I'm going to speak specifically to the 2 that are highlighted there: weatherizing your home. Coincidentally, I happen to use Healthy Homes, which Lexi is representing tonight, to have our home weatherized I think it was almost 10 years ago. And they did a fantastic job. And I didn't realize how uncomfortable my home was, or how much more comfortable it could be, until after they completed that project for us. And I've done all of these steps actually. Again, replacing, our heating system. We had baseboard heating. We replaced it with heat pumps. I think you can maybe see a heat pump there in the background up on the wall.
I see it.
Yes. I've got a remote control for here. It's amazing, how much more comfortable our home is. And it gave us air conditioning at the same time, which we did not have, which was so welcome this summer, of course. So yeah, I just wanted to mention that, as a result of, doing these things myself, I've, kind of developed some awareness and knowledge, and, I made some mistakes along the way. And that's one of the reasons why Sustainable Putnam we do energy consultations and very basic energy audits. I highly recommend getting a professional audit, but we can come into your home or we can just talk to you by Zoom or by phone and help you to figure out what your next steps could or should be. And I think that's my last slide. And so I'll turn it back to, I'll just put in the chat some information about how to contact me if you're interested in our web address. And then I'll turn it over to Lauren.
Thanks, Joe. Yeah, so I know people in the beginning are calling from different areas, if it's Westchester, if it's Putnam. So at the end of this presentation, when you're like, I still need more advice about heat pumps or insulation, you can call either me or Joe, depending on where your house is located, or you can go ahead and call one of the contractors too. So moving right along, just a reminder or an introduction that Sustainable Westchester is also a nonprofit organization. We are actually a consortium. We are a nonprofit group representing the member municipalities of Westchester. So every single municipality in Westchester County, besides one, is a member of our organization, and that also includes Westchester County itself. So we do have paid staff that provides programming of many different aspects. Our largest program is the Westchester Power Program. That's the community choice aggregation that allows customers to be opted in to receive 100% renewable energy. So you may be familiar with Westchester Power. Your house may even be receiving electricity supply through it. So we have resources if you're interested in signing up for community solar, a demand response program called Grid Rewards, and we also have resources for recycling, electric landscaping equipment, and EVs. But tonight we're talking about our Energy Smart Homes program, which is all about heating and cooling with air source or ground source heat pumps. And just to think about the why are we doing this in our homes? Why are we, besides the comfort that can be gained, why is this important to do? Well, the answer to that is twofold. One, we know that in New York State, the largest sector of greenhouse gas emissions is coming from our buildings. So if we're going to clean up our act and reduce carbon emissions, we must take action in our own homes. We also know, and you probably feel this as you are paying your utility bills, most of the energy being used in your home is coming from heating and cooling. So if we're able to reduce our costs, we're able to be more efficient and improve the environment, why not? So Sustainable Westchester's Energy Smart Homes program is here to help. We have a homeowner helper. People can call on the phone. They can email us if you are afraid to talk on the phone or too busy to do that. You can reach out. We have a list of partner contractors that we recommend. 2 of them are on the call tonight. And we also have a lot of information about the rebates, the incentives, and the financing. So the 4 technologies that we'll be talking about tonight: home energy efficiency, air source heat pumps, ground source heat pumps, and a heat pump hot water heater. So as you're thinking about making changes in your own home, you may have varying situations. Somebody on this call might be thinking, wow, my oil heating system might not make it through the winter, in which case they're probably thinking about replacing with a heat pump pretty soon. Maybe someone else on the call just got new central air last year. They probably are not going to be switching to a heat pump central air system, but they may consider doing home energy efficiency, adding insulation. So wherever you are in your journey, it's good to know about these options for heating and cooling as you're thinking about the future, as you're planning for replacements that you may have down the line. It's worth looking into. And also it's worth contacting the contractors, having them come out, do an assessment of your home, and learning a little bit about what's going on in your own heating and cooling situation. So this is just a slide of the different contractors that are on the Sustainable Westchester list. You can find all of this information on the SW website under the programs tab, and then navigate to Energy Smart Homes. And without further ado, I want to introduce Lexi from Healthy Home, or Assemblywoman Gail, if were you wanting to do introductions, or should I do that?
You can do the introductions.
Okay, I may even do that by passing it on to them, because Lexi can introduce herself better than I can. So Lexi from Healthy Home.
Everyone, how are you doing tonight? Thanks for the introduction, Lauren. I really appreciate it, and I appreciate everyone's time on their call today. Yep, so my name is Lexi. I'm with Healthy Home Energy and Consulting. We are a home performance contractor, and I'll kind of go into a little more about what that means shortly, but we are located right now in Brewster, New York. We service all of Putnam and Westchester counties, and our goal really is to help people make their homes more comfortable, healthy, and energy efficient. And everyone before me did a great job kind of explaining the advantages to heat pumps and things like, and moving towards electrification. Our goal really is to help customers take the first step towards that in reducing their energy consumption to kind of get their carbon footprint as low as possible, to one, get their house, what we like to say, heat pump ready. So when we are implementing these new technologies, to make sure we put them in a position to function as efficiently as possible. And like Lauren just said, if someone did just happen to put in a new system, that we are helping them and allowing them to still take those steps towards reducing their carbon footprint and move towards those overall goals. Next slide, please. So I kind of like to use this just as an example. I don't know how many people, it sounds like a lot of people on this call are homeowners, but you've probably gone up into attics or maybe down into crawl spaces and seen some of these things that you see in the slide right here. So you see kind of like That first picture on the left is an image of like a basement where you kind of see where the foundation of your home meets the flooring of your home. And it's kind of, is that the way it's supposed to look? Or you see ductwork that might have some maybe holes or gaps or dirty insulation. All of these things that are very common in homes are kind of opportunities for homeowners to make their homes more energy efficient. We really want to seal up gaps and cracks and make homes more energy efficient by better insulating them so the conditioned air stays where it should stay, so you don't have to use more energy to make more. Next slide. I like to use this example. If you ever get a healthy home evaluation, I'm sure this looks similar for Joe, but we use this example a lot. It's an Energy Star image that really shows where your home could be losing energy or that conditioned air. A lot of the energy that people use is to condition their homes in New York State. So we want to help people kind of take these 3 steps of find out where you currently are, like where is your home right now? Our process involves collecting your energy usage, so you have a good idea of how much energy you're currently using, and then kind of evaluate the physical structure of your home. So we really want to find out what use needs specifically. There are certainly a few things that we could say in general. You could maybe reduce your air leakage or improve your insulation, but we want to make sure we customize a specific solution to what your home needs and also where you're at in your home ownership. You might have just bought your home and you're not in a place to make a large fiscal investment right now. That doesn't necessarily mean there's not anything you can do. We kind of want to give you the information to make a plan. And then that 3rd step is take that educated action. Again, not saying that you have to install heat pumps right now or you have to insulate your entire house right now, but just helping you get that information to help you know what you can do to take the next steps to help you make that movement forward towards electrification if that's your goal. Next slide. So this is kind of an evaluation of what we encourage is first thing, like I mentioned, testing the home. Joe mentioned that Sustainable Putnam kind of has an evaluation. Healthy Home Energy and Consulting does have our own evaluation process. New York State has free evaluations offered through other contractors through New York State. I do always like to be transparent at this moment and let people know that Healthy Home does have a copay with our evaluations. We just do a lot more intensive testing, so it takes a lot of time. We do full energy modeling as well. I like to let people know that up front. We really want to test the house, get a good energy audit of your home. Next step, kind of review your solution. What are your options? What's going on in your home? What do you need? And then help you make the decisions of what you could do to reduce your home's heating and cooling load to help you get the home ready for heat pumps. So some measures might include air sealing, indoor air quality improvements, better insulation. All of those things can, 1, reduce your energy load, and 2, possibly extend the life of your current equipment. So like I mentioned, you may not be in a physical place to do everything right now, but part of our evaluation is to measure the current efficiency of your current equipment. And you may have a couple more years of life that could extend it, so you can maybe make those plans to move towards heat pumps in a few years rather than all right now. It's not an all or nothing approach. It's those baby steps, like a good example of what Joe had with those 7 steps. You can take little steps towards these improvements. Next slide. So this is just kind of an overview of what Healthy Homes evaluation process looks like. Like I mentioned, there is a copay with our evaluation, but our evaluation always includes a blower door. A blower door is actually going to measure the amount of air changes that are happening in the home. Now, this number is very, very important because essentially that is the number in building science, as we call it, that is directly correlated to your energy usage. Logically, your equipment, whether it be burning gas or maybe using electricity in the summer or maybe using oil in the winter to heat, is using a fuel to condition the air. That conditioned air leaves the house, your thermostat say, hey, it's getting cold again, and it kicks your equipment on using more fuel or energy to condition the air again. So you want to get a good idea and understanding of how well your home is retaining heat. So that blower door test is really important. And we also use that in our energy modeling software. So rather than just saying, hey, yeah, insulate the house, it'll make it better, we do actually provide you estimated return on investment as well. We always, like I mentioned, do combustion safety and efficiency testing. Just so people are aware, when I say combustion, that basically means any appliance that uses a fuel like gas or oil to create a little kind of combustion action to heat or cool the air. So we do that. And we also do obviously a thorough interior and exterior evaluation of the home. Infrared scanning really helps us see where air leaks are happening, identify drafty areas. And of course, we're also doing indoor air quality. When we're talking about reducing the amount of air changes per hour that are happening in a home, we always want to be conscious of the impact that could have on indoor air quality. You've already noticed your house might be a little stuffy, and we're talking about maybe air sealing it more. We want to be conscious of that and also make sure we're including in our proposal systems to make the home kind of feel more fresh and ensure you're getting that fresh air in an energy efficient way. Next slide. So this is kind of just an example of some heat pumps. So Healthy Home does have an HVAC division, and I know Bella's on here, so I'm just going to kind of lightly smooth over this. But this just is an example of an air source heat pump that can do both heating and cooling. I did see in the chat before, there are options other than just wall-mounted units for air source heat pumps. Like when I say air source heat pump, I mean more traditional sense of a unit outside that does the kind of scientific magic of heating and cooling the air, and then how it gets distributed throughout your home can be through ducts, like an AC system, or it can be through ductless units like that wall-mounted, or there's also like recessed ceiling cassettes that are ductless as well. There are quite a few options with that technology. Next slide. So just to kind of touch on here, in terms of what our goals here, on the left-hand side, moving to the right-hand side, I kind of like to just use as an example. A lot of people may notice they have these older radiators or old steel radiators, and they want to move towards electrification. So I always recommend adding some maybe insulation. That middle top picture is a picture of an encapsulated attic. The bottom middle picture is actually a picture of a sealed rim joist. So that first picture on my slide that had that kind of like space. This is using spray foam insulation to kind of seal and insulate that area to create a good situation for whether it be geothermal heat pumps or air source heat pumps. It's really reducing the home's energy load to ensure that the new functioning equipment can be sized appropriately and work as efficiently as possible. Next slide. That's it. That's just a picture of our company. So like I mentioned again, my name is Lexi with Healthy Home. If you have any questions, don't hesitate to give me a call. Lauren, I did see one question in the chat. Do you want me to address that now or later, or Sandy?
Sure. Why don't you address it right now?
Yeah, no problem. I just saw a quick question regarding if air sealing does increase radon risk. So when it comes to radon, we do want to be conscious of, you are correct in that by reducing air changes in the home, it can drive up radon, but that's why it's one, if there's a radon concern in the home, first and foremost, we're always going to recommend you get a radon mitigation company in there. And basically what they're going to do is, if you have a radon issue, is install a system. We do install systems called energy recovery ventilators that actually do move air as well. And some people have used those as an application to help kind of basement areas where they may already have a radon mitigation system in place that functions, but they're worried about it because they're doing more air sealing work in the home. So it can increase radon risk, but again, we're not ever, if there's a home that has an issue with radon, we're first and foremost going to recommend you go to a radon specialist and have that addressed first before we talk about doing any sort of air sealing to the home. And that is also why our company tests in. So we do a blower door before we do work, and then we actually do one again after we do work, just to make sure we keep everything in safe levels. And then I saw another one question, and Andy, if that didn't fully answer your question, feel free to send me an email afterwards and we can chat later. I saw it said, what can one heat pump be used for a water heater? I'll leave those questions about heat pumps to Belle, because I believe Belle is on here. That's correct, right, Sandy?
Right. Okay.
Yeah, I'll leave that to them.
Why don't we, Giovanni, I think is on somewhere if you would. Okay. Luenza, who is with Bell Heating and Air Conditioning and Mayapack. So these are just two of the many, many vendors that we have around in Putnam and Westchester doing this work. So Giovanni, you want to give us a little bit more detail on what you do?
Absolutely. My name is Giovanni. Can everybody hear me okay?
Mm-hmm.
All right. Well, thank you for being here. Thank you for having me be a part of this wonderful initiative. So I'm here with Bell Mechanical, and we focus mainly on the heating, air conditioning, ventilation, heat pump, hot water heater of your home. So anything having to do with keeping you nice and warm in the wintertime, nice and cool in the summertime, and nice hot showers, just let us know. That's why we're here. We do have decades of experience with this technology, although it may seem that the heat pump technology is something new. It isn't. We have actually been installing geothermal systems. That's the ground source heat pump that's been mentioned throughout the presentation. It's also known as a geothermal. We've been doing that for over 2 decades. And air source heat pumps, we've been doing that for much longer, well over 3 decades. So, any questions, definitely let us know. The best way to kind of give you more detailed information about your specific home is obviously with a home assessment. So I'm going to try to keep it general and sort of a simplified explanation of what a heat pump really does. Well, so here's, let's jump right into it, right? What is a heat pump? Just to kind of simplify, really, a heat pump is a very fancy air conditioning system, like Lexi mentioned earlier. It's sort of like the same setup as your central AC, right? You have a unit outside that is connected to a unit inside, right? In the summertime, it gives you conditioned air, nice cool air for your home. And in the wintertime, it gives you heat. And it does that through a wonderful, beautiful technology. It's like magic, right? It has a reverse valve and some other components built into it that in the wintertime, it basically does the opposite of what it does in the summertime. So essentially, heat wants to go where cold air is, right? So in the summertime, you have the heat, the humid hot air from outside wants to come into your home because it's cooler inside. And in the wintertime, the heat from your house wants to go outside where the cold air is. So essentially what a heat pump is doing is transferring the heat. In the summertime, the heat pump or the AC unit is basically taking that hot air from your house and transferring it outside and then pumping cold air into the home. In the wintertime, is doing the opposite. Is basically taking the cold air from inside your house, transferring it outside, and then the hot air from outside is actually dumping it inside. So essentially, that's what a heat pump is doing, is transferring heat. It's not using electricity to generate or create heat. It's actually using that electricity to transfer heat and therefore making it much, much more efficient than your conventional heating and air conditioning system. As Lauren mentioned earlier, HVAC, the heating and cooling of your home, currently is one of the largest contributors to carbon emissions. So we want to reduce that. We want to be more ecologically responsible, and at the same time also be financially responsible. So by reducing the cost of heating your home and cooling your home, and at the same time helping the environment, this is the perfect way of doing that, quite honestly. Heat pumps are by far the most efficient and cleanest way of heating and cooling your home. So now there are different types of heat pumps, right? We have the air source heat pump, as Lexi mentioned earlier, right? So air source heat pumps, again, it's the same setup as an air conditioning system. You have an outdoor unit connected to an indoor unit. That air source heat pump is also subdivided into 2 different types of heat pumps. You have the ducted system, which is your regular central AC setup. You have vents inside your house, and you're getting cold air and hot air through the vents. The ductless system is for homes that have no ductwork or homes that are not where ductwork is not really feasible. It's not an option. So we go with the ductless units. And there are different options for ductless. It's not just a wall-mounted unit. Like Lexi mentioned earlier, there are ceiling cassettes that sort of flush in the ceiling in between your joists, and it still gives you that central AC feel and look without the need for ductwork. And then the other heat pump is the ground source, which is really the geothermal system. That is by far the most efficient way of heating and cooling your home, simply because we are drilling into the ground. We drill approximately 150 feet per ton of capacity for your home, and we can drill up to 3 tons in one hole, which is, we can go up to 450 feet deep. And the temperature in that, the ground temperature in that depth is a constant 50, somewhere between 55 and 58 degrees, making this the most efficient way of really heating and cooling your home. And really what you're doing is you're transferring heat from the ground into the house and vice versa. Next slide. Right, so this is a representation of what a ducted or air source, I'm sorry, ductless air source heat pump really is. You have at the bottom, the outdoor unit that is really the heat pump itself is connected to the indoor unit through, you see some copper piping there. We call those line sets or refrigerant lines. That's how the units communicate. And one of the benefits really of the ductless unit is zone temperature control. Really, each one of those units, ductless units, acts as its own separate zone. So you have better control of the temperatures inside your house. If you want it cooler in your bedroom than in the living room, you can do that, therefore making it more efficient. Next slide. This is what a ducted heat pump really looks like. Again, it's just your typical air conditioning setup. You have an outdoor unit connected to an indoor unit. In this case, is an air handler, and that air handler is also connected to the ductwork throughout the house, providing you with both heat and AC through the vents. And this also can be zoned, just so you are aware. Next slide. Heat pump hot water heater. So the heat pump hot water heater, and I saw a question before, does a heat pump, I think somebody was asking if you can use one heat pump to give you both heat AC and hot water. The answer is yes, only if you're doing a geothermal. But if you have an air source heat pump, you will have or need a separate source to give you hot water. Heat pump hot water heater. It's the same, it's basically the same concept, same technology as the air source or ground source heat pumps. It is essentially using a heat pump sitting on top. If you notice that the black portion of this water heater, that is basically the heat pump, and it's using electricity to transfer heat. So it's using that ambient air in whether it's the basement or your electrical room, using that ambient air to heat your water. So essentially, it's about 2 to 3 times more efficient than your conventional hot water heater, simply because it's not using electricity to generate the heat to heat that water. It's basically using it to transfer that heat. So at the same as it's working, as this heat pump hot water heater is working, is also, becoming a dehumidification system in a sense, simply because it's using the humid air around it to generate that heat. And it's also conditioning the air. It's giving a little bit of air conditioning. So that space, that basement will stay dry and cool while this system is in use. Next slide. All right, so the ground source heat pump, as I mentioned earlier, there is a lot of drilling involved. We can go up to 450 feet deep. I think if we go farther than that, we will need a mining license. So we can't go 450 feet deep, right? So essentially what it's doing is, again, it's in the winter time, it's taking the hot air from inside your house, right? It's taking it down into the ground, and it's taking the cool air from the ground, or the cool temperatures from the ground, bringing it up and using that to cool your home. In the winter time, is doing the opposite. It's taking the cold air from your house, bringing it into the ground, and it's taking the heat from that ground and transferring it into your home. As a byproduct of this process, you will get hot water. So that is how you use one pump to give you heat, AC, and hot water as well. So hot water is a byproduct of a geothermal system. Essentially, quote unquote, you're getting free hot water for your consumption. Next slide. So this is what a geothermal system looks, because we are drilling into the ground, trenching into your home. The piping, as you can see, the black pipes that you see on the wall, that's coming from the ground into your home. You will have no equipment outside of your house. You will have zero equipment visible. Everything will be in the ground and in your home. So nothing will be exposed to the elements. So they tend to last a pretty long time. Again, this is another setup of the one before. I'm sorry, that was a split system. That was you have three units in a mechanical room connected to 3 air handlers throughout the house. The next slide is what we call the package unit. So you have both your condensing unit, your heat pump, and your air handler in one. That's pretty much it. That is the simplified, I guess, explanation of what a heat pump really does. Each home is different. Some of the older homes, we do work all over Westchester and Putnam counties. Some of the older homes that we do work in, ductwork is not an option and the homeowner still wants geothermal systems. We actually do ductless geothermal systems. Again, we've been doing it for several decades now, so we understand the system. If you have any questions, if you don't know what technology would be a good fit for your home, or if you're just curious about learning a little bit more, give us a call. We will come out to your home. We'll do a free assessment. We'll give you, what your options are, and be with you every step of the way.
Thank you, Giovanni. There are a whole bunch of questions here. I think both you and Lexi need to look at some of the questions, but I would say from now on, would people just raise their hand and we'll get to them that way. But one of the questions here from B. Weiss is about having solar system and or geothermal. How would that impact? If so, I think, are they asking the question about if you have a solar system or you can have both geothermal? It gets very complicated here, doesn't it?
Yes, you can, because basically, essentially what you're doing is you're using the solar energy to heat and cool your home. That's what will power these units.
Yeah, we like to say solar panels and heat pumps go together like peanut butter and jelly.
100%.
Yeah.
Couldn't have said it
peanut
better.
butter and jello is good. Okay. There was a question here, a concern actually by Roberto. I'm going back to like 740 something. So heat pumps are not a good idea since we don't have the energy. I don't know whether that's a Kevin issue or somebody issue.
Yeah, I wouldn't go that far, Sandy. And heat pumps are an inevitability because of the transition of the system. So they do use slightly more electricity than your standard like gas furnace. But as we're learning today, they are incredibly efficient, and they are overall a cheaper alternative. So we just have to plan the system, and we need to make sure we stay on the pace of development of renewables to keep the system reliable, so that we can accommodate the increase in these new technologies and the new heat pumps that are inevitable.
Right. I know I've gotten a call and a couple of calls to my office saying, "Are you forcing us to have heat pumps tomorrow?" And I think you've all said no. But we need to start to plan for where we're going in the future. Isn't that basically where we are?
And our goal really also is to reduce your energy load. So if the main concern is how much energy we're putting onto the grid, it's taking that first step of reducing consumption. Is right now, if people's homes are inefficient, and then you're putting in a system to match that inefficiency, you could kind of reduce your overall energy footprint by reducing your energy load first, and then making sure a heat pump is appropriate size so it can function as efficiently as possible.
Yeah, that is correct. And with with heat pump technology, obviously there is no combustion of fossil fuels. There is no fuel storage, no carbon monoxide emissions. Yes, just like Kevin mentioned, they do require a little bit more electricity than your conventional HVAC system, right? But at the same token, you're eliminating your oil bill, right?
Mm-hmm.
So, you have to look at that ROI. And again, we're being not just ecologically responsible, but also financially responsible.
So this comes up a lot. People live in private houses, but a lot of people live in condos or co-ops. Co-ops is a little different, I guess, because you really don't, you own a share. But condos is another issue. And I know we've had that. I actually had a bill on solar for condos. What are you finding with condos, individuals, wanting to do something in their particular condo? How are they going about doing this?
Yeah, the air source heat pump is definitely an option when you're living in a condo in a co-op situation. Ground source geothermal tends to be a little bit more challenging, simply because you will need approval from the board. There will be a lot of drilling. So normally the geothermal is more feasible to do in an individual home than in a condo or co-op situation. But the air source heat pump is definitely an option.
Mm-hmm.
Yeah, and if you're thinking of the future, if you're on your co-op or your condo board and you know in your capital planning a new system is going to be needed, things of the future, district geothermal, certainly there's big ideas out there that you could consider, but definitely for the individual owner in a condo, they can add insulation, they can deal with their own heating system with air source heat pump.
Yes.
Okay, how much, let's talk about the prices. I guess it all depends on what you're doing, right? And
Yes.
I know, I think Lauren spoke about, we've had programs to try to encourage people to install heat pumps with some kind of reimbursement. And I know, we had a lot of people participating, and, money is always something that we have to work to do to increase in our budgets. So any thoughts about that? How much people pay and
Can I start it talking about the rebates? And
Sure.
Joe, go ahead.
I was just going to say, yeah, there are rebates available through your utility online. You can, if you just Google your utility name, or you could go to Sustainable Putnam's website or Sustainable Westchester's website probably and find the links. But if you Google the name of your utility and rebate, you'll probably find their page. And the rebates are getting better. And in 2023, because of the Inflation Reduction Act, there'll be even greater incentives. I was actually talking to my sister on the phone today, who her water heater just happened to go, and I was talking to her about getting a heat pump water heater, and she was wondering if she could, if she could wait until 2023, but she couldn't. So, but there's still NYSEG is offering a $700 rebate, which is, significant money
Yes.
back on your heat pump water heater. So, Lauren, do you have more to add?
So just to clarify, like for the different technologies, there's different rebates that are available, different incentive programs. So if you do navigate to the SW website, go to Energy Smart Homes and then look under each technology, you'll see a breakdown of what is available based off of if you're trying to claim a rebate from your utility, from air source heat pump, and the same exists for if you're trying to do home energy efficiency work, if money flows through the state. So this chart is on each page, and actually we're updating these charts tomorrow to include the Inflation Reduction Act. So if you think about each technology for home energy efficiency insulation, rebates flow through NYSERDA. For air source heat pumps, rebates flow through your utility. For ground source heat pumps, rebates flow through the utility. And there's a $5,000 New York State tax credit, and there's a federal tax credit. Starting in 2023, through the Inflation Reduction Act, we're going to see tax credits on heat pump hot water heaters, insulation, air source heat pumps. It's going to be really big. So maybe Lexi and Giovanni, what are you saying to folks when they're saying, I want to wait to get the Inflation Reduction Act money in January?
That's a great question, because look, if you're in a situation where you need to get something now because you have no heat, you have no other option than just to get it now. You really can't afford to wait until January, right? However, if this is something that, you can't wait, as you mentioned, Lauren, there are, federal, state, and local incentives that actually, you apply for those with your accountant when you're filing for your taxes. Those are tax incentives. And then the utility incentives that are available, we actually do all the legwork for you on your behalf. We will file all the paperwork. It's about this much
Bigger. Don't
like a
Giovanni's
stack
being
like that.
Giovanni's being very nice. It's large. The stack is larger than that.
Well, yeah, I don't do the rebates myself. I have a team
I
that
do.
takes care of that. So
So
yeah, so they
I
have
mean,
a stack like that.
it's painful, but so it's same thing for Healthy Home is for the insulation and air sealing stuff. There's programs through New York State, and same thing. Healthy Home handles all of the paperwork. In terms of like just addressing the direct question of what do people say when they want to take advantage of those incentives for 2023. And in terms of all transparency, as you guys just said, a lot of them are tax rebates. So that's something that you kind of need to do on the back end of your taxes. And at the moment, we're currently scheduling in 2023. Like that's where I'm scheduling work. So we aren't really fighting it too much in all transparency. And then like for the customers that I am scheduling for now, I think a lot of them have just been kind of like, you know what, it's still a good thing. We're still getting them incentives through the state program. And I will be in terms of we're trying to change this. We're doing everything we can, but insulation and air sealing is not nearly as cool as heat pumps. So the incentives there tend to be we're not sure what the difference is going to be, but it's kind of just at the moment we're sorry, but most people still want to pursue it because they really want to get the savings that they're going to get from this heating season because their work has already been scheduled. I saw Lauren put the Rewiring America calculator in there, the chat. That's what I've been referring my customers to as well, to really see what kind of impact they can have for these plans, for their future plans.
Yes. And if this is something that I'm so sorry.
That's okay.
Just to
Go ahead.
piggyback on what Lexi said. If you're planning on, a heat pump as an option for your home, and you want to perhaps wait until 2023 to take advantage of whatever incentives will be available come January, you should start looking at your options now. Just like Lexi mentioned, I mean, we are, there's a supply chain issue. We are also, super booked up. So if you want this done in March, don't wait until January, February to get it done. Start now. And most likely you will get it done in February and March.
And there's definitely, and Giovanni, I know you can speak to this, there's a lot of steps that need to happen, particularly in the heat pump realm of things that need to be sized and properly evaluated, and all of that does take time. And if you are planning like a larger renovation, there's a lot of kind of pieces that need to fall into place.
And not to mention the geothermal ground source. It takes months to get that baby going. I mean, there is the design stage, there's the permitting process that can take up to 2 to 3 months. There's the drilling that's involved. So it's more complicated than you would think. It takes a little bit of time. So again, if this is something that you're really contemplating, that you've been thinking about for your home, well, right now, really, there is no better time to do it than now because of all the incentives. But if you are planning on doing it come first quarter 2023, really start doing your research now.
Can I just ask you just a question about weather? Do the heat pumps or geothermal, everything works in however cold or hot the area is, right? It doesn't really matter. It's not dependent on the temperature.
Right. So for instance, the ground source, as I mentioned earlier, we drill so deep into the ground that the ground temperature is always the same, regardless the ambient temperature. It could be 120 degrees in the summertime. It could be 20 below zero in the wintertime. That ground temperature will remain the same. So yes, that's for the geothermal. However, the ground source, air source, if you are looking at the air source as your primary source of heat, your main source of heat, or only source of heat, you definitely want to go with a cold climate air source heat pump. A cold climate air source heat pump will give you heat even at sub-zero temperatures, 17 below.
Oh, okay.
And it's
So-
also very important to make sure the system is sized, so those systems can support the right amount of air exchanges in a home. So sorry, Giovanni, didn't mean to cut you off.
No,
but
no, yeah, that's.
There's a
absolutely
reason
correct.
why Giovanni and I work well together in that we're able to ensure homes are ready for the equipment that they're installing.
That is correct.
Yeah,
Can
just
one
add-
pump,
Oh.
did somebody want to say something?
I did, Sandy. I just wanted to, from personal
Yes.
experience, having had heat pumps for almost 4 years now, I left my electric baseboard heating system in place, thinking, well, maybe I'll need it to supplement the heat pumps. I've never turned them on again. It's been incredible, and it we've had sub-zero temperatures in the past 4 years, and I have had no problem keeping my home more comfortable now, actually, with the heat pumps than it was with the electric baseboard system.
Okay, somebody had a question. Can one pump be used for a water heat pump, water and air, or 2 pumps required? I don't know whether we've answered that question. Maybe it's individual.
I did, but I
Okay.
have no problem speaking to it again.
Okay,
Ground source, the geothermal heat pump, the ground source heat pump, geothermal, can be used to also generate hot water. Hot water is a byproduct of the process for the geothermal. However, if we cannot do geothermal, if you're not contemplating geothermal and you're going with an air source heat pump, that air source heat pump will not be giving you hot water. You will need a different a unit for that, like the heat pump hot water heater. So if you're going with an air source heat pump, we will have to have a different system to give you the hot water, whether it's electric or heat pump hot water heater. I definitely recommend the heat pump hot water heater. But if you're going with a geothermal or ground source, that can also give you your hot water.
okay. It really sounds to me like everybody is unique and every property is somewhat
Yes.
unique. And you need to talk to somebody specifically when we're giving general,
Correct.
general concepts, right?
Yes.
But, because somebody has a question here, Bernie, too. How much do you save if you go from oil heat to water heating to a hybrid water heater? Is it cost effective? I think you have to look at what the bills were, probably what's been going on in that property, or
Yes.
am I wrong?
No, every home is different. And every homeowner is different. I mean,
So vastly different.
in the winter time, I may want to keep my house at 75 degrees. You may like it at 65 degrees. So there's a lot of, it's difficult to kind of give a general idea. This is how much everyone will save, because, each home is different.
And also keep in mind
Yeah.
occupancy and how you use your home can vary. Oh, sorry, Keith, Kevin, I didn't mean to cut you off, but
No, keep going.
if you are currently living in your home as is right now, and then you add, maybe you have a baby, all of a sudden you want to keep that area of the room a little warmer and things like that, and how you use your home as time, or maybe you have a college student who leaves the house and now you're using that part of the home less. How you use your home is also like a pretty large impact. And again, Giovanni touched on it, but comfort is like a big driver. Someone who calls me and says, oh, I'm cold, and they're constantly keeping their thermostats at, say, 80 degrees, and they're saying my house is never getting to temperature. Well, I might walk into that house and be boiling, but I'm not going to say to that homeowner, well, you're wrong, you're not cold. It's how you feel. And so I think that's also really important when you're adopting these new technologies and things like that. It's very specific to you, how you use your home and how you feel. Again, someone may not notice a draft or a smell, and I might notice that draft and smell. So it's very kind of specific to you. And that is why it's important to have someone out there to evaluate the home and make sure they're having a good conversation with you of what you're looking to get from a project.
That is correct. And for any specific questions like that, I mean, feel free to call the office. You can ask for me. I'm not always available, but if you leave me a message, I will get back to you. I'm very good at returning messages, but we do have a great team. I mean, I have professional licensed engineers on my team that we can evaluate your home, not just from an HVAC perspective, but also from an engineering perspective, and give you the best setup for your home. We want to make sure that the system fits your home and not the other way around. That's why it's extremely important to have a professional assessment done. Like I said, we offer these assessments at no cost to you. So feel free, give us a call.
There's a question here about where to get rid of the old boiler, all the hot water pipes. Where are we putting those? Do you know? That's another environmental issue, I guess.
Yeah, it's not something that you just throw in a dumpster. It has to be done. There are steps, protocols to follow. So yeah, but when we come to your home and we are installing a heat pump, whether it's air source or ground source, we will remove your old equipment and we will dispose of it properly. It's not going to be left in your backyard for you to deal with.
Right. So what about the noise in the house? I know I have a dehumidifier and I can hear it going on all the time, but are they noisy? I don't think so. Are they?
Your boiler's probably
right.
more noise than
Right.
your boiler, your furnace, whatever you currently have it's going to be louder than the heat pump.
Right. So you will give people an idea of what their they spent X amount of thousands of dollars, when they will start to see a return on it. You probably give them some kind of an idea.
Yes.
As you go forward, right?
Yeah. And again, this can be done individually.
Right.
And Sandy, a bit of maybe it's public service announcement here, and I don't want to end on such a down note, but I have a feeling that Giovanni and Lexi are going to get very busy here soon enough. We're looking at the what we call the forwards for the average cost of the commodity, natural gas and oil, because it has such an impact on the wholesale cost of electricity. And it's going to be a really difficult winter. The price of electricity will be impacted, but the cost of natural gas and oil, and for those folks that are relying on those commodities to heat their homes, all of the tips on energy efficiency and this new technology that you've been given today, you'll find very important in the months to come. And we understand that especially after last winter, the number of people that start to inquire and make these choices on these new technologies. And I love the peanut butter and jelly analogy, because when you co-locate the distributed solar on your roof with these technologies, I mean, that's the goal. And this winter is going to be really very difficult if you're using if you're using oil, you got an oil boiler or natural gas furnace. So seek assistance if that's what you need. There's government programs to help with paying your bills. And I think the information you got from this forum today from all the participants, but Lexi and Giovanni with that practical information really probably going to be very useful in the months to come.
Thank you so much, Kevin. And I think, although we'll probably go on with questions all night, but we're going to stop. That was a wonderful way to kind of wrap it up as to where we are. Obviously, we're all going to have to get more information about heat pumps and specifically for our own properties, and look forward to making those changes as we need to. And I just want to thank all my panel, both Kevin and Lauren and Lexi and Joe and Giovanni, and especially to Claire Wexted, who's my communication director. She pulled everybody together. And I just want to thank everybody that has been on this Zoom. I hope you've gotten lots of good information and probably more to come. And if you need any information about any of our panelists, just give my office a call, 914-941-1111, or email me. You have my email, gailifs@newyorkassembly.gov, and we will get more information to you. So I just want to thank you so much. And I know it's there's so many more questions, but we committed to just an hour and a half. So I want to thank everybody for being here. Thank you all. May you have a very nice rest of the week and a nice weekend. And we're not looking forward to the winter, Kevin.
The older I get, the less and less
You weren't
I.
looking forward to the summer either.
Right.
Well, maybe some people like snow sports. Let's live on a positive. Anyone who skis or snowboards or snow sports, we got that. Let's just go with that. Thank you everyone for your time. Have a great night.
Thank you
Thank
for
you for
having
your
us.
time.
Thanks
and
for
Thank you.
organizing.
Thank you,
Yeah.
everyone.
Thank you.
Bye.
Thank
Bye,
you.
everyone.
Night.
I'll just end it, I guess.